Problem number 33, page 571. Solve the right triangle. And we have a right triangle, KLM. KLM. Right triangle. More than that, a few sides are given to us. This is 4, that's of length M, and this one is L. We also know that angle K is 34 degrees, right? And you have to solve this triangle. How should we start? Well, okay, that's a good start. So we can find angle L right away because we know L is complementary to K, which means the measure of angle L will be 90 degrees minus the measure of angle K. And that equals 90 degrees minus 34. 56 degrees. And that answers one part, right? So we got all the angles, now we have to find the sides. We know only one side, two are missing. How can we find them? Ideas? Sine. Sine of which angle would you like to use? Sine of angle K. Well, let's go with that. I will use a different color to make it pretty, right? Sine of angle K is given to us from this triangle by what ratio? The opposite side, which is what? LM, right? Divided by your hypotenuse, which is KL or LK, it doesn't matter. Now, we know that angle K is 34 degrees. So by substituting in all the values that are known to us, we have what? Sine of 34 degrees should equal the opposite side, which is 4, divided by our hypotenuse, KL, which is missing, and we're using variable m for its length. We have a ratio, or an equation if you want. You have to solve it. By cross-multiplying, you will find out that your m equals, well, you know, let me show you what's happening here, right? I can write the sine of 34 as sine of 34 degrees over 1, and you have the two cross products, sine 34 degrees times m, and 1 times 4. I will write it that way first. So I have sine 34 degrees times m equals 1 times 4, which is 4. And now obviously if you want to solve this equation, you have to divide by m's coefficient, which is sine 34 degrees. And you will divide both sides by that. Sine 34 divided by sine 34 is 1. M equals, what is 4 divided by sine of 34 degrees? Using your mighty calculators, right? 4 divided by sine of 34 will equal 7.15. 7.2 is good enough. 7.2 units, right? Alright, we have two sides, we have the angles, we have one missing side. How can we find that missing side? Side L is missing. What is L in this triangle? Is it what? A leg or a hypotenuse? Leg, right? M is the hypotenuse. So you can apply either Pythagoras theorem, or you can go with another trigonometric ratio. You want to go with the same angle. Well, for angle K, what is L and either M or, I mean, either KL or LM giving you? What trigonometric ratio would you like to use? Sine, cosine, tangent, which one works? You guys, I mean, take your, lucky pick. We use sine. Let's use, I don't know, cosine. What is cosine of angle K? Cosine of angle K will be given by what side? The opposite or the adjacent? Adjacent divided by hypotenuse. For this case will be what? Adjacent Km divided by your hypotenuse KL. Alright, well, Km is not known, is L. KL, we found it, is 7.2. And you have a proportion here, right? Or an equation if you want to use it that way. We know that cosine of K, actually to find L here, you will multiply by what, both sides? You want to remove that denominator, right? So I'll multiply by 7.2, both sides. 7.2 divided by itself is 1. You find that your L, I'm switching here, I'm putting L on the left, equals 7.2 multiplied by cosine of K is 34, right? Cosine of 34 degrees. And that equals what? Using your magic calculators, you find that 7.2 multiplied by cosine of 34 equals 5.96, which is approximately 6, right? Approximately 6 units. And this is it. Now you can check to see how accurate your answers are by applying Pythagoras theorem. You can check to see if the sum of the squares of your sides, of your legs, right? 4 squared plus 6 squared, if that is close to 7.2 squared. 7.2 squared. And 4 squared plus 6 squared is 52. 7.2 squared is 51.84. That's close enough. Obviously we use some approximations here. So we did it. Well, the answer for the last side is 6, right? So we have angle L 56 degrees, M 7.2, L 6. That's about it.